Question 5 from the mini test 2 part 1. So you've got a kayaker that wants to travel across a river and they want to go due east. They can paddle at a speed of 1.3 meters per second in still water, and there's a current of 0.95 meters per second flowing due south in the river. So this question, they've given you the resultant. So you want the resultant to be pointing due east like this. So that's what you want to end up with. You know that there's, let me just put some arrows on this, so that's the resultant vector. But there is a current in the river pointing due south, so that would be down this way. So that's due south like that. And that's 0.95 meters per second. So 0.95 meters per second. So these are at right angles. Now, this is the resultant vector. So if you want to find the resultant vector, you add vectors tip to tail. So the other vector must go from, so the tail of this one to the tail of this one, like this. So that would form the vector triangle. So this vector plus this vector gives this resultant vector, which is the due east vector. So this would be the 1.3 meters per second speed that the kayaker can do in still water. And then this is the angle you're trying to find. So, well, you could find this angle, but they're all relative to east. So take this angle here. So that means you want to do theta equals to, well, that's the opposite and that's the adjacent. No, it's not, that's hypotenuse. So like that. And that is the adjacent. So then we've got the opposite and hypotenuse. So SOHCAHTOA, so it's going to be sine. So theta is sine inverse of 0.95 over 1.3. Oops, 1.3. And you put that in the calculator. So sine inverse of 0.95 divided by 1.3. Get so 46.95. So 47 degrees like this. So 47 degrees is this angle, and it's sort of north of east. So it's going to be 47 degrees north of east. So the answer to that one is D.